An amazing time. Hope you had a wonderful break, but we are right back. And our teacher, Mohammed Ali, is going to take us through the high education, high education, actually. You're going to learn more from him. Welcome aboard.
Thank you. Welcome on board. Ahead, but if they'll be joining us, it will be an added advantage. In our previous session, we had introduced a topic on SADs. Whereby we introduced what is a SAD, and in the definition we knew that it's an irrational number, which means it cannot be represented in the form of A over B. So, example of SADs, we have that in our previous session, we saw that the example of SADs, there are numbers like √2, √3, and so forth. And even we went further to mention the order of a SAD, whereby for those under a root, they are of √2 of order 2, those under cube root are under order 3, and those under fourth root and so forth. So for example, those under fourth root are under order 4. Okay. For the benefit of those who were not with us in the previous session, we'll go directly into the operation of SADs, whereby we divided the operations into two. In the first, we had addition and subtraction. Of SADs. So, in this operation, we see that SADs can be added or subtracted if and only if they are like. They are like SADs. This means, or i.e., they have So, in our statement, we are told that SADs can be added or subtracted if and only if and only if, which means that otherwise they cannot be subtracted of or added. So they are like surds. Like surds, for example, we have 3 root 2 plus 5 root 2. You can see those numbers under the root are the same, have the same value. We have 2 under the root and 2 under the root. So it means the value of the number under the root is the same. So there, our condition for addition and subtraction of surds has been catered for. So in this example, we take the whole numbers, we add them. It will be 3 plus 5 into bracket multiplied by root 2. So the answer you will get, which will be 8 root 2. Let's look into other examples. Eight, 5. Here we have that the number, we have to be very careful to ensure first, before doing the operation, that the number under the root are of the same value. That's when we can proceed with the subtraction or addition. So here we are under the root, we have 5, and also here we have 5. So it means that we can proceed with the subtraction operation. So here we'll take 8 minus 2 into bracket, then we multiply by 5, root 5. So it will be 6 root 5. So that's to do with subtraction and addition of surds. You can write one question, which can be a practicing, as we'll be proceeding. You can look into this question and see I have 2 root 3 plus 4 root 3 minus 2 root 5 plus 4 root 5. So as a hint, we have the surds with root 3 and those with root 5. So we first ensure those with the same value of the root, we put them together, and those with the same under root 5, we do there as well. Okay, we can do it together. We'll be having 2 plus 4 root 3. Then we have minus 2 root 4 root 5 plus 4 root 5. We can turn it the other way around, or we can also, it's 4 into bracket 4 minus 2 root 5. So 2 plus 4 you get 6, and 4 minus 2 you get 2. So our answer becomes 6 root 3 plus 2 root 5. Let's go to the multiplication and addition, multiplication and division of surds. So we are told that surds of the same order can be divided or multiplied irrespective of the number Okay, we are told that surds of the same order can be divided or multiplied irrespective of the number under the root. When we told of order, we are referring whether it is under root or cube root or fourth root. So, or fourth root. So, numbers with under the root will only multiply with numbers with the ones with root, and those under cube root will multiply with those under cube root as well. So in here we have three laws which I'm going to illustrate here, which will enable us to do the multiplication and division of surds. Our law number one, we have that root A multiplied by root B is equal to root A B. Then law 2, we have that root A divided by root B is equal to root A over root B, which equals to root under 1 root A over B. Then thirdly, we have that of A squared into bracket root or root A squared is equal to A. Okay, these are the three laws which will enable us to do the multiplication and division of surds. Quickly, let's go into like 3 examples and see we have root 3 times 12 root 3 times root 12. This is equivalent times to 3 times 12 under root, which is equal to root 36, which is equal to 6. Or we say root 6 squared, which is equal to, the root will cancel with this one and we will remain with 6. That's our first example. Into our second example, the one manipulating division. We have root 12 divided by root 3. So this one is equivalent to root 12 over root 3, which equal to 1 root 12 over 3. So when we divide 12 divided by 3, we'll get 4, which is equal to root 4. And we know that 4 is equivalent to 2 squared. So the square and the square root will take each other and we remain by 2. Okay. Then you can have some examples for exercise purpose. We can copy these 4 numbers and try them for the division and multiplication of surds. Then we'll be going on to the rationalization of surds. We thought that surds may appear in fraction. Rationalizing the denominator of such a fraction finding an equivalent fraction that does not have a surd on the bottom side. Okay, we are told that surds may appear in fractions. Rationalizing this denominator of such a fraction means finding an equivalent fraction that does not have a surd on the bottom of the fraction. So when you are told to rationalize, you should understand that you are just being asked to find an equivalent fraction, which means in the process you'll be getting away with the surd under the fraction or at the denominator, but you are not doing anything else than just finding an equivalent fraction. Let's look into an example. For example given, you have 6 over root 7. You are told to rationalize. Second example, you have 6 plus root 2 over 2 root 3. So in the first example, we multiply the denominator and the numerator by the root. We multiply by root 7. We also multiply by root 7. So the root multiplied by the root 7 multiplied by root 7, you'll get root of 7 squared. This will be 6 root 7 over root 7 squared, which is equivalent to 6 root 7 over 7. And by doing so, you have already rationalized. The second example, you have 6 plus root 2 over 2 root 3. So we multiply both the numerator and the denominator by root 3. When we multiply on the top, we'll get root 3 multiplied by 6 plus root 3 multiplied by root 2. So on the denominator, it will be the root 3 and root 3, which will be 2 root 3 squared. And then both on the top side will be having 6 root 3 plus root 2 multiplied by 3. Up to there, on the bottom side we'll get 6, since when we solve the root 3 of 3 root of 3 squared, it will be 3. Multiply by 2, you get 6. Then here we'll be having 6 root 3 plus root 6. And up there, you have rationalize. In the second condition of rationalization, if the denominator involves or subtraction, the square root we are told that if the denominator involves addition or subtraction with a square root, to get rid, use the difference of the square and multiply both the numerator and the denominator with the bottom side expression, but with the inverse operation. In this case, an example, when you are asked to rationalize such a number, a number or an expression without side, we call it a conjugate pair. So in this is from the algebraic expression or identities, whereby so in order to express this or to rationalize it, we'll take it's being borrowed from the difference of two squares in the algebraic identities. So when you multiply the top one, you'll get 14 minus 7. 14 minus 7 root 2 over we'll be having 4 minus 2 root 2 plus 2 root 2 plus 2. So these ones will cancel each other. So we end up having 14 minus 7 root 2 over 6. That's our answer. We have already rationalized. So to wind up, I'll give you two examples. You do them as an exercise on also to practice, because without practicing it may be easily to forget. So number 1, the second number, so this is also another application of rationalization. This one, you just find the conjugate pair and you multiply the denominator and the numerator. In the second one, you multiply the multiple or the product of this one and this one will be like our LCM. Then we'll use it to express this one into rationalized form. Up to there, I think you enjoyed the class. In our next session, we'll be looking into indices and logarithm. Thank you.
What an amazing lesson. Hope you had fun of your life.